All right. Hi, everyone. Welcome. We are going to kick off in 1 minute. Not sure if there's anybody left outside, but we'll give them another minute and then we will start. Perfect timing. Yeah, there's still people coming in. Come in, sit down. We're about to kick off. Okay. All right, let's get going. So, welcome everybody to Cloud Native London. We are a strong, open, diverse developer community dedicated to cloud, data, and AI based in London. My name is Cheryl. I am your host for tonight's event. And our agenda for tonight, we have 3 talks. The first one is the data collection Gambit, why the false sacrifice is no longer necessary. That's from Rob. Our second talk is at 7:15, and it's testing in cloud native, time for a new approach by Ole. Then we're going to take a 15-minute break at 7:45, go outside, grab drinks, come back at 8 o'clock, and we'll hear the next decade of cloud native from Ihor. At 8:30, we're going to wrap up, and you can come with us to the pub downstairs. We're going to go to the conductor, which is straight out the front door on your left. It's 1 minute, and hopefully keep chatting from there. Our sponsor for tonight is TestCube. Thank you so much. Ole is going to do his introduction during his talk, but please round of applause to say thank you. And now a little bit about you. So please grab your phones. You can scan this QR code. We're going to do a bit of live polling. You don't need to download anything or just open up this web page. And I'm going to ask 2 questions about you and then 2 questions about how you use Cloud Native. Our first question, is this your first time at Cloud Native London? So you should see a yes and a no, and you just press if it's your first time or not. Looks like, yeah, people are figuring it out. So we are about 50-50 yeses and nos. Maybe the yeses are pulling ahead now. We are also streaming to YouTube and to LinkedIn Live. So there might be a handful of people joining us at home who are also figuring this out. Looks like the yeses are pulling ahead. We've hit 61%. Somebody's coming in with a no. All right, looks like it is kind of settled around 60-40. But either way, I'm very happy that you made the time to come here and be with us. Next question, what is your job title? Your options are architect, application developer, backend developer, engineering manager, DevOps/platform engineer, security engineer, or anything else. Just pick something that's kind of closest to what you do. Looks like, we've got a nice spread today. One of everything, at least one of everything. DevOps and platform engineers kind of holding out the strongest, but a bunch of others as well. So if you are an other, then please feel free to introduce yourself as well and tell other people what you do. And the DevOps platform engineers just hitting 30%. Okay, let's keep going with our live poll. Hey, overqualified. Overqualified? And we all overqualified? No, all of us are very perfectly qualified to be here. Okay, next question. When it comes to observability data collection, What is your current strategy? Vendor agents everywhere. We need the rich context they provide. Open source only. We prioritize independence over features. We do a hybrid approach, different tools for different services. We're actively migrating from vendor to open source, or honestly, not sure what we're using. People a moment to think about this one. Okay, so looks like hybrid approach is leading the pack. This question comes from Rob. So is this what you expected? Is this a surprise?
Yeah, I would say this is what I expected. I'm assuming that a lot of people are working at large organizations where they've got teams that have their own observability governance, which is the reason why there's a general hybrid approach across the whole org. Slightly low on the vendor agents at the top. I would have expected that to be higher, but generally that looks about right.
Okay, cool. Thank you very much. Next question. How are you running automated tests in your delivery pipelines? What's an automated test? We run tests manually where needed. We run them as part of our CI/CD pipelines. We run them asynchronously in reaction to system events. We do it on schedule, or we just go in production. Looks like there's one pretty clear winner here, 83% saying they run them as part of CI/CD. So Ole, is this good news for you? Is this what you expect?
Yeah, I'm glad no one had the first option. Oh, sorry about that. Never mind. Yeah, I think it's pretty much as expected. I think more people are running in production than they'd like to admit, maybe, but this was just you can only select one option, I think so. Thank you.
Nice. Yeah, maybe some people are not admitting quite truthfully. Okay, thank you. Keep this polling service open on your phones because we're going to do Q&A after the presentations with this as well. But thank you very much for joining in with the live polling. Okay, I need a selfie for social media. So I'm going to stand on that side and then I need everybody to smile and wave. Big smile, big wave, okay? Come on, bigger. Everyone needs to look like they had a good time. And if you would like to come up and speak at one of the Cloud Native London events, or you can also sponsor us, or you can share the events that your company is running, you can go to cloudnativelund.com. We're booked up for speaking slots until March of next year. So just plan ahead because you can always sign up for a speaking slot and then, don't ask you for your talk until February. I really welcome first timers, people who haven't spoken much or, don't have much experience. So please, we're a very friendly crowd. Feel free to sign up. And that is it from me. So now I'd like to welcome Rob, who is our first speaker, to the stage. Round of applause, please, for Rob.
All right, very, very excited about this. So yeah, great to be here. Thanks for everyone joining today as well. Just before we kick things off, actually, can we give a big round of applause to Cheryl and Eunice as well for putting this together? So yeah, you're probably wondering who I am. So my name's Rob King, and I'm a solutions engineering leader, and I've worked in the observability space for some time now. So tonight we're talking about the data collection Gambit and why the full sacrifice is no longer necessary. So as a 2000 rated chess player, I do love a strategic metaphor. And tonight, I'm going to show you how the observability game has fundamentally changed. The moves that were forced sacrifices just a few years ago, they are now winning positions. Beautiful. So quick background. As mentioned, I've spent over a decade in observability. So I have covered the whole ecosystem, really. So I am an OpenTelemetry contributor. And in addition to that, I have also worked at vendors like Keysight, Datadog, Dynatrace, and Chronosphere, deploying observability out at an enterprise scale. So I've seen the evolution from both sides, the open source perspective, but also the proprietary vendor agent approach as well. So I am going to catch you up to speed and let you share what's changed recently. So we'll skip straight through that. And for years, this was the fundamental choice that every engineering team had to make. On one side, we have the vendor agents. So it's the rich context, the deep actionable insight. However, it does come at a cost where you're going to experience some vendor lock-in to a degree, where you'll be locked into their ecosystem of various different dependencies, whatever platform you were to choose. And then on the right-hand side of the screen, we've got open source that offers that maximum freedom. However, there is a compromise on the level of detail. So typically limited to basic metrics, and observability gaps are also possible as well. So it was a painful choice between essentially functionality and freedom. And that trade-off has shaped every observability decision for the last decade. So in chess, a forced move is when you have no good options. You're compelled to make a move that actually weakens your position. And that's exactly the historical trade-off that was represented historically. So you were forced to sacrifice either functionality or flexibility, and there was no third option. But the thing about chess is the board position can change everything. So let's establish a baseline and level set for a second. Observability is the ability to understand the internal state of a system by examining its telemetry data. So I'm referring to metrics, traces, and logs in that regard. So observability is about instrumenting and collecting the data, but then also forwarding that data on to the observability platform that's then going to generate the actionable insight off the back of that. And the business case is really compelling for observability. This is just, I'm literally skimming the tip of the iceberg with some of these stats here. As an example, though, consolidating logs, metrics, and traces into a single source of truth typically reduces the mean time to resolution of P1s by up to 50%. We can see standardizing observability, 50% of users were able to benefit from faster development, and the average return on investment for implementing observability annually has worked out as an average. Obviously, it's a spectrum, right? If you're a B2C e-commerce platform, it's going to be much more than this, and the inverse as well. But on average, the return is $500,000. And those data points can be effectively categorized into 4 key areas. There's the improvement in the mean time to detect, mean time to resolution of incidents, the ability to reduce downtime, which ultimately reduces revenue loss, being able to save costs as well. So identifying bottlenecks on the back end that could potentially benefit from optimization, and so in turn could lower your infrastructure self-hosting costs. And also the developer experiences as well in that regard that comes with increasing the visibility in general. So OpenTelemetry is an observability framework, and it's a toolkit to facilitate the exporting and collection of the telemetry data, such as traces, metrics, and logs. The delineation between OpenTelemetry and a proprietary vendor agent approach is that OpenTelemetry is completely open source. It's tool and vendor agnostic. And here's the critical timeline. OpenTelemetry was first launched in 2019. And then the semantic conventions were broadly stabilized across the pillars of observability in 2022. And bringing us to today, 2025, where we have now achieved production vendor grade instrumentation. So fully production ready. So that strategic landscape that I was alluding to earlier, that's fundamentally changed, and the forced move is no longer forced. So in 2022, Gartner predicted that by 2025, 70% of new cloud native application monitoring will use open source instrumentation rather than the proprietary vendor specific agents. How are we doing on that front? We're actually doing pretty well. So this latest Grafana observability study, which is this year, 2025, found a remarkable 75% of respondents are now using open source licensing for observability, and 70% of users that were sourced during that study noted that they were using both Prometheus and OpenTelemetry in some capacity. So a lot of progress on that front. Now, there's a whole host of obviously reports out there and further analysis. This is another example. So InfoQ's latest trend report, 2025. In the early majority quadrant, you can see OpenTelemetry has been placed there. So it's coming after the chasm. It's no longer an early adopter. It's considered an early majority. And that gives us production vendor confidence. In addition to that, though, because it's still quite early in the timeline, there's likely a competitive advantage as well that can be gained from deploying OpenTelemetry too. So it's not theoretical anymore. This is, as you can see, mainstream adoption. So this is the game changer. Let's look at this comparison. So OpenTelemetry, feature for feature, is effectively matching those proprietary vendor agents now. We have metrics, distributed tracing, zero code instrumentation. We have rich context, both vertical and horizontal, logs, collector pipelines, custom metrics, W3C trace context, continuous profiling now as well. Plus there's Gen AI monitoring and also real user monitoring in an experimental state too. So that technical sacrifice there is now gone. So we're getting effectively parity. It's the same capabilities, but with OpenTelemetry, there's the expanded strategic options. And when I mentioned rich context in the previous slide, so I'm alluding to multiple different factors, right? And this is what's gonna, so data's great, but unless there's actionable insight behind it, it's effectively just noise. And so the service topology view, that is that dependency map that automatically gets created as you ingest traces into your platform, mapping out the services and their different dependencies. The business and custom metrics, which are going to provide additional useful context. And then also an understanding of the end-to-end journey. So that distributed trace, what are the technical touch points that transaction passed through on the back end? And then finally, the full stack mapping as well. So from the infrastructure and network layer all the way up to the app and web tier, what is that looking like vertically? So we're getting a full understanding of the horizontal and the vertical. And historically, we would need vendor agents to generate that context for us because they would have some secret source in the agent and it would unpack all of that client side and then beacon that telemetry data back to the SaaS observability platform. However, OpenTelemetry does a really good job of collecting that data now. And there's also SaaS platforms out there that can actually weave together that context of understanding the end-to-end and vertical server side. So you're able to get that same level of actionable insight without the vendor lock-in that comes with going with a proprietary agent. So what's your next move to gain production level visibility using OpenTelemetry? I'm going to cover 3 key strategies. And to stay on topic, I'm going to explore them using some chess opening analogies. So we've got the Sicilian defense, which represents full adoption. It's a confident, well-prepared commitment, and you're going to accept that early complexity for long-term control. So this is ideally suited for those greenfield applications with a shortened time frame of around 3 to 6 months on average. So effectively, this is for teams that are looking to go all in with some level of observability instrumentation. We have the Rui Lopez. This is a balanced classical chess approach and also mirrors an OpenTelemetry approach as well. So you would run OpenTelemetry in parallel with your existing setup, systematically validating everything as you go. And this would be ideally suited for risk-averse organizations. Typically, it takes a little bit longer, an elongated timeline there, but you're going to get that zero risk validation. So it's providing a safe path to production. And then my favorite chess opening, the English opening, is a flexible and positional approach. So you're gradually going to develop and adapt, mixing OpenTelemetry with your existing tools strategically. And this is best for those larger enterprises. So if you've got complex infrastructure, a lot of different moving parts, the timeline's obviously going to be longer, but this approach will enable you to, and your teams to potentially achieve that strategic vendor footprint reduction without disruption. And investing in OpenTelemetry, it isn't just about what you get today. There's a whole community of contributors and maintainers that are enhancing this project. And also, for example, Elastic kindly donated their continuous profiler to the OpenTelemetry project, which profiles via eBPF. So that's a new signal that we're now collecting. There's in general better support for events and structured logs, semantic conventions as well that can normalize your data. And also, there's now high quality data in experimental phase for AI agents and copilots to help with incident remediation, cost analysis, and performance optimization. Now, speaking of AI, OpenTelemetry now has semantic conventions for Gen AI models. So that's the AI agents, the prompt response capture, and token usage tracking. So complete vendor agnostic AI observability. And I'm going to show you what this looks like in practice in just a second. I've built out a multi-service AI agent system and instrumented it using OpenTelemetry's Gen AI semantic conventions. So what you'll see is an orchestrator, a stock data collection, AI reasoning, sentiment analysis, and notifications, sending that same data to an observability backend. And in this example, I'm using Chronosphere. So here's a quick look at the OpenTelemetry semantic conventions that I have kind of actioned as part of this demo. So you can see here there's Gen AI semantic conventions, AI agent semantic conventions, and also some custom metric and business context included as well in that regard. So let's jump into the demo. Just before I do show you that as well, let me just set some expectations here as well. This isn't about stock trading. And I'm going to show you an example of an AI agent going out to the web, fetching some stock data, fetching some headlines, and then doing some clever analysis on it. It's not about that. It's about demonstrating OpenTelemetry's Gen AI capabilities. So I built this in an evening, and then I instrumented it with OpenTelemetry using their new semantic conventions, added rate limiting and cross-service tracing as well, within a few hours, just to highlight how that complexity gap between OpenTelemetry and vendor agents has really diminished. So if I can do it in a couple of hours, it's that gap has gone. So let's jump in here. Am I presenting? Perfect. Okay, so I'm just going to play a short video here and then jump into Chronosphere. So just about to run my Python script. So the AI agent I've created in Python. I can now either run it ad hoc straight away or set up a regular frequency to give me visibility throughout the day. And what it's now doing is it's going out to the web and it's for my shares, my stocks that I'm interested in. It's getting the latest price for those. And then also it's scouring the web for any headlines that are relevant and is classifying them as either negative or positive. So that's going to feed the AI engine with some context in regards to the peaks and the troughs. So it's now done that. And what it's now doing is it's making a connection to LM Studio. So I've got my own self-hosted LM Studio, and I've got various different AI models running. In this case, I'm running Qwen 3, and we can see the response that AI model has returned. So it's taken the data that it's been given. It's also compared all of the previous runs. So it's got a historical understanding of all the old data. And then it's providing some insight. So you can see here, Tesla's facing some negative headlines, and they're related to some legal issues that could be why you've seen a drop in Tesla stock. And unfortunately, my portfolio is experiencing a slight downturn on the day that it was run. So I've got the AI agent running there. Now, what I want to do is mitigate risk, right? So as with anything, I want to know if it goes down, why has it gone down? I would ideally like it to stay up as much as possible because I don't want to miss any significant drops or peaks in the market that I could potentially capitalize on. And also, are there any bottlenecks within the application itself that could be improved and enhanced? And that's where the OpenTelemetry instrumentation comes into place. So I've instrumented with OpenTelemetry, and then I'm sending it to Chronosphere. So Chronosphere, for those that aren't familiar, it's they're leaders within the Magic Quadrant, but they're an advanced observability and data ingestion platform. And so what we can see on the screen here, let's remove operation, is a list of all of the services that I have created as part of my AI agent system tooling. Just let that load in like so. Perfect. So yeah, see 5 different services here: news intelligence service, the portfolio AI agent, and the LLM call as well at the bottom. So these services here, we're currently coloring them or grouping them by the request metrics. That's our throughput. We could also look at performance or errors. So of those services, which ones are experiencing error rate? And we can actually take that one step further. We can say, well, of all of the times where there was a problem, which service was the problem originating? And that's a leaf error. And so the leaf error is effectively the root cause, and it's identified this LLM analysis service as the root cause service. Now we can slice and dice this however we want. We can leverage the semantic conventions that are present within my AI model that I've coded in. So of that, for the operations, let's just let the data load in there. We can see all of them were for one particular operation for that LLM analysis service, which is the Gen AI portfolio analysis operation. So that's great. We haven't had to manually search through dashboards or anything like that. We've identified the service, and we've also identified a specific operation responsible. Now, earlier I mentioned about context and how awesome context is. So this is our live topology map, and I'm just going to zoom out a touch here. Yeah, okay. Let's expand the time range. I should have pinned that there. So this is showing us all of the various different services and their dependencies to other services. And it's always, the reason that that's useful is it's always nice to be able to understand architecturally, is our application behaving in a way that it was designed? And if it isn't, why not? Where are there bottlenecks, etc.? So if I zoom in here, I was planning just to share a video on this, but technology let me down. So I'm doing a live demo instead. But it's all good because it seems to be all working nicely on this internet connection. So what we can see here is those AI services, their dependencies to others. We can now color them by, say, errors. So we can see delineation here of this is the specific service within the chain that's actually causing problems, creating the errors. We could also recolor that as well to be able to view it from a performance perspective. So it seems that the portfolio service could potentially benefit from some performance optimization work, because we can see that degree of shading there, coloring there on the donut icon itself. And so what we're going to do now is just jump straight into a trace. No, let's go down. Yeah, perfect. Okay, so let's go into our trace list. We'll just take the top trace as an example. So trace is the trace of a transaction. So it's a single request and viewing it past all of the technical touch points on the back end. So at the top of the trace, we've got a lot of lovely context there. We can see the root operation hitting the portfolio AI agent service. We can see that there was an error generated within this trace itself. And we can see that end-to-end journey. So the AI agent hitting the data service, it's initializing, it's then calling out to the news intelligence service, which is then polling Yahoo, other financial APIs that I've programmed in there, and it's getting the latest stock prices and headlines as well. Until finally it makes its way down to store that data in my local database to provide that historical context for the LLM. And then it's then making a request out to the LLM directly. And on the right-hand side of the screen, what's really nice is we can see those Gen AI events. So we can see the span logs that have been captured. In this case, it's returning an error. So we can see the AI request and the error details. So in this case, it's a 400 error code, and it's due to an error rendering prompt with a particular template there. Scrolling down, we can also see all of our tags, including our latest OpenTelemetry Gen AI semantics. So got a good understanding there of error messages. We can also see our token usage as well there as well. So that's something that we could use from a cost analysis perspective. Obviously, process data, metadata, it's all there within that single trace. And so what I've shown you there is really powerful. Instrumented in just a couple of hours, we have an end-to-end journey, complete visibility of an AI agent making calls out to the web and then sending that data into an AI model. And whenever there's an issue within Chronosphere, just within a couple of clicks, we've been able to delineate the root cause of that. So what was the key service where the problem was originating, and what was the operation responsible for that? So thank you very much. And just to conclude, the false sacrifice era is over. So you no longer have to choose between functionality and flexibility in observability. OpenTelemetry has achieved technical parity while still preserving those strategic options. The question isn't whether to adopt OpenTelemetry. The question I pose to you is which strategy fits your organization the best? Thank you very much.
Thank you. Thank you. That was fantastic. Okay, let me switch on to this side. And we're going to switch to questions. Yeah, okay. Why do you think there is a slow uptake of OTel from major ISVs?
Yeah, it's a great question. And
you keep answering.
Yeah. So that's a great question. And I don't have any direct experience myself with a slow uptake for ISV. I assume it's due to a capability issue and also a time to deployment and value concern that they would potentially have. It would very much depend on the timeline. So when they were looking to roll out OpenTelemetry, perhaps at that stage it wasn't as well adopted. It didn't have such a broad set of capabilities and features as it does now. It may also be that those ISVs as well are less cloud native focused, and they're more on premise, so old servers, legacy tech stack, which wouldn't be an ideal fit for OpenTelemetry. Just to be transparent as well, that's typically where OpenTelemetry would play nicely with an incumbent legacy monitoring tool that they already have in place. Yeah, so in a multi-tenant application, are there any general strategies to return metrics data to our tenants? Just to qualify that question, when we say tenants, are we referring to observability platform tenants? What tenants are we talking about? Yeah. Yeah, great question. And definitely would recommend to implement some tagging governance so that you'd then be able to delineate based on the different company names and any other ways that you want to slice and dice that data. So when I'm alluding to tag and governance there, the metric label combinations, right? So as part of those metrics, have some labels that are then meaningful, and that could then be used as part of routing calculations. And actually, just once those metrics hit your observability tenants, you'll then have the context to be able to view on a dashboard, a single pane of glass, metrics for different clients, metrics for different applications easily. So yeah, in summary, if you're looking at a multi-tenanted application, I would look to understand, is there a way that I can tag that and potentially somewhere higher up the stack? So if it's multi-tenanted rather on the infrastructure itself, I'm assuming you're using Kubernetes to orchestrate everything. So by the namespace would be a typical go-to if that's a good way to logically separate on. Thank you. Do you think OpenTelemetry is gaining enough support in the tools and library space? For example, CI/CD products emitting OTel signals as opposed to just internal observability capabilities? Great question. So I would say the short answer is no. I think there would be, and I think there would definitely be benefit for gaining more support in terms of additional tools and library space for those CI/CD products, just to augment visibility and to then have that visibility present with the rest of your observability as well, rather than having a siloed approach. Observability in one CI/CD product and then observability in your SaaS observability platform, as an example. With OpenTelemetry, you could bring that all together. And it also mitigates the risk of a CI/CD potentially marking their own homework, having a different set of eyes on that data. I can only see as being a good thing. Has the vendor lock-in shifted from the collector agent to the functionality of the back end? Is the open source space keeping up with vendors there? Has the vendor lock-in shifted from the collector agent to the functionality of the back end? Yeah, absolutely. I mean, you've got some large observability platforms out there that have thousands of engineers that are working on their platforms. And so their platforms are comprehensive. They're able to slice and dice the data, provide that automated insight, and sometimes are driven by causal AIs and machine learning and clever automation there. That is very much, in my experience, what the developers are focused on, is that back end, rather than the collection of the data itself. Because once you've collected all of the appropriate and useful signals of telemetry data, in my experience, there doesn't tend to be too much more that you could do to improve that, other than improving performance and, collecting more signals that perhaps you hadn't considered. But there's definitely less of a moat there for OpenTelemetry to be able to close up on the other proprietary vendor agent approaches out there, just due to the fact that there's just not that many different sources of data. And so And then, can you tell any use cases? Would someone like to provide some more context there? Any details around the type of use cases you'd like me to share? Yeah, fantastic. Yeah, absolutely. So OpenTelemetry, yeah, absolutely. It will work in a kind of a distributed architecture. It works, on cloud. It's all about providing that visibility. So yeah, I could definitely share some stories about war stories and also, great success stories as well. And definitely we're seeing a lot of great adoption of OpenTelemetry now that the, as mentioned, that feature function gap between the vendor agents has closed, and then there's now parity. So yeah, thank you for your question. Okay.
That's it. All right, round of applause, please, for Bob. Now we're going to welcome to the stage Ole for our second talk. So thank you very much.
Hello, hello. Oops. Okay, great. Thank you so much. Thanks for having me. It's great to be here. I'm happy. We're happy to sponsor this event, and also happy if you go to our website afterwards and just check us out. We have an open source product that you can have a look at. I'll get back to that a little bit later. I'm the CTO of TestCube. I've been doing testing in open source for 20 years. If you've ever used a tool called SoapUI, that was my creation about 20 years ago. Probably not. And then I was also very involved in the Swagger ecosystem many years while I worked at SmartBear. But something that kind of annoyed me when working at SmartBear was testing in CI/CD more specifically, because at the time, testing was very tightly coupled to CI/CD. And CI/CD tools are not great. At the time, it was mostly Jenkins, great at running tests at scale and not great at test reporting and not great just in general from a QA perspective. And that kind of started the idea of, would there be something we can do about making testing easier? And then along came cloud native and the shift to Kubernetes, which also suddenly highlighted a lot of challenges with testing. And I'm going to talk about those and the horrors of testing that hopefully TestCube can help you with. Just a high level, how does cloud native, the changes in cloud native, how does that impact testing? And as you know, shifting cloud native means a lot of different things. One is moving to microservices, to containers, and using some kind of container orchestration framework, like most commonly Kubernetes. It's about making applications much highly distributed, regionally, within clusters, etc. It's about embracing infrastructure as code, using dynamic and ephemeral infrastructure. It's about moving from synchronous to asynchronous pipelines if you're doing GitOps, or if you're doing progressive delivery, or if you're doing all of the above. All of that kind of complicates how you're delivering software. And I just had to put AI on a slide, so I did it at the bottom. If you're using generative AI to generate code or tests or infrastructure configuration, that all is kind of driving your decisions on how or not driving, but it poses a challenge of how do you test all of this efficiently? How do you continue running tests efficiently as all these things are changing? Moving from exaggerating now, from a very monolithic approach where you had one code base that was compiled into one artifact that was deployed on one server, going to this, as you can imagine, testing changes. I'm sure you've all seen this kind of figure 8 lying down. Testing is across the entire pipeline, and it's been that for a while. This is not new to cloud native. What's changed is maybe, like I said earlier, how we do testing and how it's kind of injected into that pipeline. But today you hopefully run tests if you're coding locally. You're running tests as part of your builds. You might be post-build running component tests in your CI tool. If you're doing a release process to some kind of artifact repository, you might be running some tests before you do that. Then you might be running tests after you deploy to a staging environment. You might be running tests, infrastructure tests in your infrastructure as you provision that. And you might be running tests in your operational infrastructure as part of progressive delivery. And as I was alluding to earlier today, you might be running tests in production, which actually a lot of companies do, more than I would have thought. I'll get back to that later, which is totally fine, of course. But if you then multiply this, if you have a large organization, you have 50, hundreds of microservices, each of those might have its own kind of pipeline that it's going through. Each of those might be deployed to a bunch of different environments. Each of those teams might be empowered to choose their own testing tools. Some are using modern tools like Playwright or, well, reasonably modern Cypress, or K6 for load testing, or they're using Selenium, JMeter, Artillery, Gatling. They're using other tools. There's so many tools out there, and they obviously in a bunch of different versions. And what you end up with also, what you end up with is a kind of tool sprawl across all of these different pipelines. And as your pipelines become more asynchronous, you also might want to trigger these tests, not just like in CI/CD, like we heard in the survey, but you might want to trigger those tests based on Kubernetes events. I want to run my test when I make changes to my infrastructure, not necessarily when I deploy something in GitHub Actions. Or I want to run my tests based on some event in an external tool, or just on a schedule every 4 hours, which is actually pretty common. I'll come back to that. So just to kind of maybe wrap up the biggest challenges that we're at least seeing and seeing in the space is, one is, how do you, with all that sprawl of all those different environments, how do you maintain consistent execution and triggering of your tests across geographic clusters, across testing stages, across local and ephemeral environments that you might be creating as part of your CI/CD pipelines, across cloud providers, and across all the different tools. Today, we talk to a lot of customers who have 3 CI/CD tools. They have Jenkins that they've used for a long time. They started using GitHub Actions 4 years ago, and now they're moving to Argo CD, and they have all of those in parallel. And how do they make sure that the same test gives the same result running from all of those tools, regardless of where and which environment they're running those tests? So it's a problem of scale, but it's a big problem, as you can imagine, if tests don't consistently fail or pass. One thing, test observability. Rob talked a lot about observability. In the testing space, the concept of test observability is very similar. It is about getting insights into all the artifacts and logs and metrics, et cetera, that were collected in correlation to an execution of a test. That could be both from the system under test itself, and it can be from the testing tool itself. So if you're running a load test, you might want to get metrics from the load testing tool on transactions per second, average response times, but you might also want to get metrics from the system under test around memory consumption, I don't know, IO, disk IO, network IO, et cetera. And getting that observability in a highly distributed system, let's say you're running an end-to-end integration test that touches 30 microservices that are spread out across multiple clusters in different locations, having all that one view in one place, you could get that in an OpenTelemetry observability tool, but that's not usually where dev and QA want to troubleshoot failed tests. They want something more context specific. And it's usually those tools that Rob was talking about are not built for this specific use case. They might have the data, but they're not presenting it in a way that's easy to consume. There's also another level of test observability, which goes more into reporting, into metrics, into like KPIs for how many, what's our pass fail ratio? How many tests are we running? Did we run all the tests we need to run for the latest release, et cetera? So test observability has a bunch of different dimensions to it, and it just gets very complex with all those dimensions that cloud native application infrastructure adds to the mix. Also about just correlating, you might have a test that runs, it passes, and now suddenly it fails, and you didn't know that there was actually an update to the ingress controller in your cluster, which had some issue in it that caused one API not be able to talk to another API. And seeing that correlation between changes in your infrastructure and other things and the test results can be really, really hard, unless of course you're using OpenTelemetry maybe and other tools. Another challenge is around release promotion. How do you know when your application is ready to ship? If your application has, once again, 50 microservices, how do you promote? What do you actually promote? It sounds great that you can just, in a fluid way, deploy new versions of your services, but usually you want to bunch them together into some kind of release. And how do you know when all your quality gates for that specific release have been met? And that can be really hard to kind of measure, once again, in the context of cloud native. And then I want to go back to this talk about moving from synchronous to asynchronous delivery pipelines, because historically, if you were using a tool like Jenkins, or Hudson, or if you go further back in time, you would have one tool that would orchestrate the entire delivery process. It would build your code, it would maybe deploy that code, it would run tests against it, and then if those tests went fine, you might let that tool even deploy it to a production environment. Usually there was a manual step at that point where someone would manually run acceptance tests and then promote that to a production environment. Today, what we see is a much more asynchronous flow where you have maybe a CI tool building your code, building your artifacts, pushing a Docker image to your image registry, which kicks off a CD event or some other kind of event, which triggers Argo CD to deploy the latest updates to your infrastructure into your cluster. And then once Argo CD is deployed, or Flux, or whatever GitOps tool you might be using, you might want to be triggering a progressive delivery process using Argo rollouts or some other tool that promotes your release across your different environments using blue-green or canary deployments. And as part of all that, you might want to be able to trigger tests. And how do you do that? Once again, the challenge here, how do you do that consistently? How do you make sure that you have visibility into all the tests that are being run, that you can see the results of all of those tests and troubleshoot them, et cetera, in a consistent way across all those different pipelines and testing tools that I mentioned earlier? I'm obviously kind of exaggerating the picture here, but this is a real challenge as companies adopt cloud native and have both the backpack of a more synchronous pipeline and want to move to an asynchronous delivery process. On the flip side, cloud native also actually provides a bunch of opportunities to make testing easier. First of all, you can embrace the same declarative approach that you have for your applications, you can also embrace for testing. So you can leverage constructs like CRDs and pods and jobs and events, et cetera, to trigger tests, to define tests. So that can then tie into your GitOps workflows and work well with everything else you're doing. So it doesn't necessarily mean that testing has to be on the side. It can be actually be participate in this move to cloud native. Events is a big thing in the Kubernetes world, as I'm sure you know. CD events is a standard driven by the CD Foundation, which has specific events to help you with testing and continuous delivery and build pipelines in a more asynchronous way, adopted by tools like Tekton and Argo workflows as well. You can also leverage, of course, the capabilities of Kubernetes to scale your testing, to run your tests, because Kubernetes is really great at scaling and allocating resources to tests. So instead of letting your tests run either in GitLab or GitHub or by an external test execution vendor like Sauce Labs, Browser Stack, there are a bunch. Why not leverage the existing Kubernetes infrastructure that you have and all of those capabilities in there at a much lower cost and much higher flexibility if you have the means to manage them. So there's a lot of, it's not just problems, there's also opportunities by shifting to cloud native when it comes to testing and test execution. There has to be a Venn diagram in these presentations. So here's one. The concept of continuous testing is something that's reasonably well known, at least in the testing community. And it's kind of adjacent to continuous integration and continuous deployment, which I'm sure you're familiar with, CI/CD, which they're all kind of centered around continuous delivery, which is meant to be automated, integrated, and provide observability into each of the steps. And as you can see, continuous testing obviously ties into these, but also has certain needs that are very specific to testing. And to help testers and developers and DevOps people to troubleshoot their tests. So this goes back to observability that I mentioned earlier, and also to the gatekeeping across lifecycle stages. So, and this is maybe to highlight a little bit why CI/CD tools aren't great for testing at scale. They might be great at triggering a unit test or a postman test or something like that, but they're not great at giving you that holistic picture of all your tests running across all your pipelines and managing that efficiently. And usually people start maybe with a more defensive approach. I don't know which chess opening that would be, maybe the French opening, but to kind of and do everything in Jenkins. But over time, they realize that they're starting to have to manage a lot of, or not Jenkins, GitHub Actions. They're starting to have to manage a lot of YAML workflows and trying to orchestrate those, and they don't really scale. And they move the GitHub runners into Kubernetes, which doesn't really work as you want it to, et cetera. And it just gets very, very messy. It's kind of where those tools fall short. So just breaking it down, and I think we saw this in that initial infinity loop as well. How would you test in a perfect scenario? Locally, while you're developing, you can run any kind of test, obviously. During CI, as before, you would run unit and component tests. You'd use the build tools that you have, NPM, Go, Maven, Gradle, depends on how you're building your software. And post-build, pre-publish, when you're publishing your artifacts to a repository, you might be able to run some end-to-end UI component tests if you have the luxury of provisioning ephemeral infrastructure. Maybe you'd be using something like vCluster or Octeto, or there's a bunch of vendors out there, also open source solutions to do that. As part of your CD process, you can run tests post-deployment, and that could be either asynchronous, basically listening to events in your cluster and realizing, okay, something's been deployed, let's kick off some tests, or you can let the CD tool itself trigger the tests that you might want to run. So Argo CD or Flux, well, not Flux, but Argo CD, or if you're using Octopus Deploy or something like that, they can kick off tests, of course. Or if you're doing progressive delivery, once again, like a Canary rollout or a blue-green, you can tie testing into that to help you understand if your application or component is ready to be promoted. And those tests are usually more holistic. So it'd be end-to-end tests, API tests, baseline performance tests. Usually we don't see people running full-scale performance tests in an automated way because you need to have full control of your infrastructure. So you're not messing with or being augmented by other things going on or messing with others. Security tests, something common to run there, also infrastructure testing. And then post-deployment, which could be pre-production, it's security testing, once again, is super important, acceptance testing. And then I'll talk about testing in production, which is one of those things that people say you shouldn't be doing. We've been doing a podcast series, and we've had 12 guests now, and all of them are running tests in production. And their argument is, one argument was, well, if it doesn't work in production, why would we have it? We have to run tests in production because we want to know that things work for our users, end users. The other was there's so many things being deployed continuously to our production environment. We need to have some kind of safety net to make sure that things are still working. And you might not run the full end-to-end integration test suite in production, but you can definitely run lightweight functional tests. Some do chaos testing, and there's of course an overlap with just monitoring. If you're just doing Checkly or some other tool just to monitor availability, and there's questions where you draw the line. But we definitely see a lot of companies having testing in production as a core testing practice in their process. And if that works, that's fine, of course. Talk a little bit about infrastructure testing. This is actually a pretty big thing from what we can see, since it's so easy to dynamically provision infrastructure. Platform engineering teams provision infrastructure, both ad hoc for teams that are going to build things. They might need infrastructure temporarily to run tests. You might be provisioning ephemeral infrastructure as part of your pipelines. So having some way to test that infrastructure is ready for whatever it's meant to be used for is actually super helpful. So you might be testing that the resources it's supposed to have are available, that it has the network topologies that it needs to be, that it needs to have access to, that the right RBAC policies, et cetera, are in place. Dependencies, is Prometheus up and running? Is the ingress controller there? All these kind of things are good things to validate before you actually let people use that infrastructure. And this is also something that can be done synchronously or asynchronously. And there's a bunch of tools out there. Helm has a built-in Helm tests, as many of you I'm sure are aware. There's a tool called Chainsaw from the people behind Kubernetes. So there's definitely tools to help you do this. And it's something that we see also being done quite often. Okay, where do you start then? If you're not doing any testing, which is of course shocking, but that could be very well the case. I think in CI, you must have some kind of unit tests and component tests. Nice to have end-to-end tests in ephemeral infrastructure. Setting that up is harder than it sounds. But of course, once it's running, it's very nice to have. In CD, we'd say it's a must-have to have some kind of automated end-to-end tests, API tests, security tests, depending on what kind of application you have. and doing some kind of manual performance testing. I think nice haves today is infrastructure testing, as I mentioned earlier, and also automated performance and chaos testing is a nice have. Like I mentioned, doing automated performance tests is hard because you need to be sure that your infrastructure is up for those tests. And then in production, must-haves, basic functional monitoring. Nice-haves would be to do full chaos testing and end-to-end testing. So there's a lot you can do. Testing is usually not the first thing people are excited about when they're building new stuff, but it's one of those things that comes around in the end. So how do you actually go around implementing this? So what we see today is that people try to leverage their CI/CD tooling by scripting, using the YAML syntax of GitHub or GitLab, or in Jenkins, writing Gradle scripts or whatever you might be using. And the pros of that is you have everything in one place and it ties neatly into the CI/CD tools that you have. But it does kind of gets unwieldy after a while. It's hard to maintain and it locks you in to that vendor, and it doesn't really scale very well when it comes to test execution specifically. The other possibility is to integrate point tools as solutions. So you're basically cobbling together and building a Rube Goldberg machine, where you're kind of using, one tool for reporting, another tool to, usually the CI is still at the heart of this. The pros here is that you'll have the right tool for the job, but the cons will be that it's just, once again, a lot of maintenance work, and you'll end up having dedicated engineers maintaining this. And finally, there could be on the market, if you're lucky, a dedicated solution for continuous testing, which is kind of purpose-built to solve this problem. And that maybe solves a lot of the problems that I alluded to in the previous slides. The cons of this solution could be that it doesn't have the depth of the existing point-to-point solutions, and it does also require some integration work. And I'm guessing, not surprisingly, this is kind of where I was going. I'm going to talk a little bit about TestCube, which is really kind of the product that we're building to solve and help teams, organizations solve many of these testing-related problems. I just want to check how I'm on time. So TestCube in itself is a cloud-native test orchestration platform. So it helps you manage all your tests. It has an execution engine built on Kubernetes. It provides test observability to make it easy to work with your test results, and an analytics portal. And it kind of ties into all of these different pipeline issues that I talked about in the previous slides, and that we see people often struggling with in larger deployments. The core tenets of TestCube is that it's vendor agnostic. So whatever testing tool you're using today, for automated tests, it'll work with TestCube. It'll work with any CI/CD tool that you're using, and it'll integrate with any other tools that you're using for Grafana, for metrics, for example, or issue trackers or test management, etc. It's very developer-centric. There's an MCP server if you want to build an AI agents on top of your, in Cursor or in VS Code. It's very Kubernetes native. It uses CRDs and ties into kind of all the low-level technologies in the Kubernetes ecosystem to help you run tests at scale. So it's really built around that. High-level architecture, TestCube has an agent that you deploy in your clusters. This agent is open source. You can run this, download it from GitHub, install it in your cluster, and start running tests without any involvement of us as a company or the commercial product. The agent will use the CRDs to run your tests. It'll spawn jobs and pods. It'll aggregate all the logs and the artifacts, etc., generated by TestCube, and write those into MinIO and MongoDB for storage. And then you can query that and use that as kind of a central database for all your testing results. On top of that, we have a control plane that you also install in your own infrastructure. So this is an on-prem product. This is not a cloud-hosted solution. Almost all our customers run this on-prem. The control plane manages your agents. So for people who want to run tests in multiple clusters, multiple regions, or want to, they have one test, they want to run it in staging prod or in the US and in Asia and Europe, etc. They can do all that through the control plane, which then also adds, typical control plane functionality like RBAC and AI and scheduling and a bunch of things that kind of are maybe more to the enterprise deployment scenario. And super quick demo. I'm going to show you what it looks like. And this is live, so let's see how that works. So this is This is the test cube dashboard exposed by the control plane. And we're just looking here at a bunch of different, let's see if we have network connectivity. We do. Awesome. So these are different tests for different testing tools. Someone say a testing tool. Anyone using Playwright here? Awesome. There we go. So here we have a Playwright test that's basically just running. We can look at the latest results. It basically just runs a Playwright test, generates a JUnit report. I can trigger this test from my CI/CD pipelines. I can trigger it here manually in the UI. I just can't see because there's stuff in the way. Okay, I'm going to run this test right away so you can see now that it's actually running. So what is happening now is our agent is cloning a Git repository. It's running dependencies. It's going to run this Playwright test and show us the results here in the UI. While it's running the test, it's also measuring resource usage, and we can let that run for a little while and also have a look at some other tests here. Let's see if there's something interesting. Here's a K6 test. K6, the load testing tool that runs across 3 different nodes inside your cluster for a more distributed load test. We can look at the latest executions here. Also look at kind of what the resource usage was for this specific load test. So if you're running massive load tests, you might want to be able to see how much memory, CPU, et cetera, were they consuming. This can help you really troubleshoot the tests themselves. You also get the HTML reports generated by K6 here in this specific test result. And as you can see here, there's a bunch of different workflows. Let's go back to that Playwright test that we ran. Oh, it's still running. Okay. Let's say I want to run that test from, I don't know, if I'm running Tekton, we'll show you here kind of the code you'll need to put into GitLab or GitHub Actions or Circle CI, regardless of which tool you're using. Make it easy to trigger these tests from inside your CI/CD pipelines so that you can still have the same results in the same place. Also, I mentioned triggers. So here you could define which Kubernetes events you might want to use to trigger the execution of your tests. And finally, sorry, that was the wrong button. Webhooks is also available to kind of help you integrate testing into other tools. So if you want to be notified on Slack or Teams, or if create Jira issues, et cetera, et cetera. So TestCube really tries to tie into your ecosystem of pipelines and tools and how you run your tests and be that central pane of glass for all your testing activities. So I will stop there. That was a super quick demo. If someone is interested in more, I do have an MCP server, which is actually super cool. I'm happy to show that afterwards. There's, of course, a lot more features to show in the product itself. I'm not going to go that. I'm just going to say thank you. Hopefully this was reasonably interesting. I know testing isn't usually top of mind, but it is something that most people struggle with sooner or later. So please keep TestCube on the mind when you get there. And thank you so much. All right. Awesome. Okay. Flutter integration test. I don't know what that is. It's my bad. Who asked the question? Flutter, is that a framework for? Well, if you can Dockerize them, then it's supported. So I'm guessing it would be supported, yes. Yeah. So get back to me afterwards and we can figure that out. So I'll say yes to that. Do you think may not put off GitHub Action managed confirmation distribution to excuse costs? Yeah, I think people try to move those. What we've seen is they move those to their own hosted GitHub runners to kind of circumvent the cost. They'll still have to pay the cost for the infrastructure that they're hosting the GitHub runners on. That's usually a first step. Those GitHub runners aren't great at running tests at scale because ultimately it's still one process that runs in one Kubernetes pod that runs everything inside it. So it doesn't scale out your tests across multiple pods in your cluster. So yes, I'm talking about a different thing. yes, I do think people think are put off by that. And I do think that's why they move them to using Git-hosted runners, self-hosted runners, but that doesn't always get them as far as they want to. Yes, it is always the for security testing. Yeah, you can definitely run security tests with TestCube. Security testing is, well, it's one of those things that you run them when it's too late, I guess, because we realize that there was some kind of vulnerability and then you put those things into place. So definitely security testing is something you do late. You can definitely run security tests with TestCube. Complex test data, that's a great question. So within, I didn't go too deep into how the product works, but when you define those test workflows that we have, you can also, as part of that, define connections to other services that can provide test data either statically or dynamically. So if I know there are test data vendors out there that you could hook into the execution of tests in TestCube. So, but if the person who asked that has a more specific tool in mind, I'd love to talk more about that and see how that could be wired up just out of personal interest. Security testing at monitoring level. So would that be to run security tests as monitors on a schedule, or what was the context there? No one? I think you can run any test that you run with TestCube as a monitor, right? You can just say, run this every 5 minutes. Security tests, maybe that's a bad example, but maybe every hour or once a day, etc. So definitely the use case for that is just, especially today when infrastructure is fluid and you might update it all the time. So running a security test often is a good practice anyway, just to make sure that, that small update to Nginx or whatever didn't introduce some vulnerability in our infrastructure. Yeah, I think that was it here. Okay, well, thank you so much.
Another round of applause, please. Hello. Okay. And we are going to go to a break. So we've got 15 minutes now. Please come back at 8 o'clock, but please go out, help yourself to any other drinks, and be back at 8. Thank you. All right, sit down. We're going to start in 1 minute. But that didn't mean go silent. You can talk for 1 minute. I think it should be on.
Works? It works. Perfect. Okay, fantastic. Can resume. All right. Hello, everyone. For the third talk for tonight, it's almost 8 p.m., so I believe you're not so much bored. So my name is Ihor Dvoretsky. I'm a senior developer advocate at the Cloud Native Computing Foundation, and today we'll speak about literally the next decade of the cloud native. So the fun fact that this year the CNCF does celebrate its 10th anniversary, and like it's a big milestone for us as a foundation, and it's a big milestone for all of us as the big in the global community. So gonna speak a little bit about that. It's not supposed to be the deep technical talk as two of them have been before. So just kind of like a bunch of slides right here and kind of like highlighting some of the stuff that has been happening around for the last 10 years and where we are heading towards to. Does it work? It does. All right. No. Okay. Cheryl, I don't see. I do see. Okay, it works. Sorry about it. All right. So basically, the brief story, kind of like in a single slide, how had it started. So basically, the CNCF, kind of like the concept and the idea of the CNCF as the vendor neutral foundation, has appeared back in early 2015 when a group of the vendors, companies, partners have joined forces and specifically have discussed it with the Linux Foundation at OSCON. For the true veterans of the industry, you may remember what the OSCON is. It's one of the, it used to be one of the most notable open source conferences in the world, driven by O'Reilly. Doesn't exist anymore, so basically they've suspended their offside, events business in the COVID era, like pre-COVID era. But that's literally the part of the history. So basically the concept here was that Kubernetes was the next big thing in the world, and like everybody, like literally all the big players in the industry did understand it. It was owned by the commercial company. It was owned and developed primarily by Google with the support of the multiple of the various vendors in the open source world, but it was still owned by the single commercial company. And that was kind of like, so first of all, it was the kind of like the blocker for the different big actors in the game to join the forces with their potential kind of like commercial competitor. And the second one is literally the fact that like there is no company in the world that may run the project at the same pace, at the same velocity as the big and global and the vendor neutral community can. So basically, around 10 years ago, the group of the companies have joined forces with the Linux Foundation to establish the new foundation around Kubernetes, and where Kubernetes could join as the first and the anchor project. So that was basically the beginning of the CNCF history. The big news here is that like it was not called for the for multiple reasons. It was not the Kubernetes Foundation. It was literally the Cloud Native Computing Foundation, despite the fact that Kubernetes was one of the biggest and notable projects right there. It was the single one at that point of time. At the same time, it was the project that had to build the ecosystem around it. So basically, later on, the governing board has been established for the CNCF with the representatives of the funding companies, and like later on in the year, the first formal governing board meeting has happened, and at the beginning of the next year, the technical oversight committee, basically the technical the technical oversight board or kind of like something like that has been established basically with the people and the representatives of the industry, where multiple folks have been kind of like have had their own experience and like their own knowledge with the stuff that is going on in the industry, and may kind of like provide the deep insights into that. So basically, like the intention was there is to kind of like to bootstrap the technical body around Kubernetes and various projects that are around. And like formally, Kubernetes was accepted as the first project right there. So basically, today we kind of like in the past 10 years, we've literally grown up to like literally one of the biggest open source foundations in the world, with the significant number of contributors and the maintainers, with people who are like literally making who have made like more than 1 million pull requests and like lots of millions of the contributions to the projects. And these days we do host more than 200 projects under our umbrella that are kind of like divided into the different levels of maturity. And obviously, like not all of the projects have the same level of adoption as Kubernetes, for instance, or OpenTelemetry that we've been speaking about today, or projects like Prometheus or Envoy. But like some of the pretty much brand new and new to the industry projects, but all of them are hosted under our umbrella. And literally, we have representatives in our community, either from the contributions or people who are running the meetups like this one. Literally almost from every single country in the world. And the formal stats confirm that Kubernetes is the second open source project in the world after Linux, literally the Linux kernel, as the highest velocity project. So literally, whoever of you have been using Kubernetes, have been contributing to Kubernetes, have been doing some kind of the cloud native and Kubernetes meetups, as some of us are doing here, you are contributing to literally one of the most notable projects in the open source history. And here it's kind of like the, well, funny enough that we basically we do have the heat map. Actually, it was kind of like something that folks from GitHub has shared with us a few months ago. They've been running some kind of the internal experiment somewhere kind of like at the GitHub, and they've been trying to collect the heat map of the contributors of the most kind of like most actively contributed projects all around the globe. And so they did this stuff with Kubernetes. And other cloud native projects, the CNCF projects, and like here we have our maintainer heat map, literally with the global spread of our maintainers according to their affiliations on the GitHub page, on their respective GitHub profiles. And the same with you know, like with the contributors, where we do have like close to 300,000 contributors all around the globe. So on this slide, you know, like it was one of the first slides that like we've ever created for our slide decks at the CNCF. I recall myself presenting it to the different group of people and in the different audiences in the different cities of the world, like back in 2017 or so. But basically, this is the slide that does highlight the history of the cloud native movement and like how we ended up here with Kubernetes and like all that fancy cloud native stuff that we are speaking here, literally daily, and like whoever is doing that at their day job. So we literally can like have some history here. So I will not dive in so much right here, but basically the concept here is that all of us have started with the kind of like using and deploying the applications in the non-virtualized environments. Literally, those of us who like remember the like the pure bare metal data center procurement process and like all that stuff that we've been doing kind of like in the late 90s, where close to zero virtualization and containerization technologies did exist in the production world. So we've been dealing with that stuff where it was close to impossible to easily scale up and scale down the the infrastructure that you may have, the applications that could be deployed on top, and the different stuff that could be used right there. So in order to scale up your existing bare metal infrastructure, you had to literally procure some of the new servers, install them into your own data center, for instance, if you own one, or kind of like share that stuff with the colocation providers and like all this. And so like kind of like pretty much painfully, if you'd like to scale up and down dynamically and easily as we can do these days. Later on, we had a new kind of like the next big revolution with the virtualization software, where VMware, as one of the vendors, was one of the pioneers, and some different tools and technologies and different vendors also appeared on the stage, where like literally we could do the same with the hardware, and like we still had to use our own bare metal hardware and like all that stuff, but at least we've been able to virtualize it, so run kind of like multiple virtual machines with the, let's say, different operating systems on top, and also like try to use those resources more efficiently on our own hardware. Next big thing has happened with the revolution of the so-called infrastructure as a service provided by the public cloud providers. Amazon with AWS was one of the first ones, not the single one, like also kind of like the veterans of the industry may remember companies like Joint, some other stuff, but basically Amazon was the new pioneer right here, because like they've made it public. It was literally the public cloud because of the public, you know, like it was available like close to everyone if you do have just a credit card to link to your account, and like you can easily start spinning up your infrastructure, or spinning down again, like if you are kind of like looking for some mechanisms to optimize your costs if you don't need that scale so much. And so it was great. So it was kind of like the big solution in the infrastructure world, how you can, again, like having enough money on your credit card, say, or on your banking account, how you can easily build, easier. So build your infrastructure in the easier way, rather than the traditional process of kind of like consumption and procurement that we used to have in the past. But that was still about the infrastructure. Developers have been requiring the different tools, because, like, you know, the layer of the kind of like the abstraction layer between the kind of like the pure infrastructure, just the operating system, I don't know, like Ubuntu server or something like that, and the end user application that your developers in your company are developing is kind of like, it's a little bit different in terms of the levels of abstraction. So the concept of PaaS, the platform as a service, has appeared on the stage. Also with the kind of like one of the most notable vendors in this era was Heroku, who have kind of like literally presented that concept together with a few different concepts in like specifically simplifying the lives for developers. And that was kind of like the next big revolution at that point of time, which is well known as platform as a service, known until these days. Jumping back to the infrastructure, so we had the next big thing called OpenStack. So many people may remember OpenStack, and like obviously it still does exist, just like it's not so much a big thing as it used to be like 15 years ago when it just appeared on the stage, when Rackspace, NASA, and some other commercial vendors and the open source community have joined forces in the effort to develop, pretty much the replacement or an alternative or the supplement to, literally the AWS, the open source version of the AWS, or the similar infrastructure that could be used, that could be easily deployed on your own hardware, in the data centers, and your bare metal, like all that stuff. Specifically, it was useful for the telecom providers, for the financial institutions, for the different companies that have been looking for the way how they can easily store either their customers' data on their kind of like on their own premises, or like due to different regulations, like all that stuff. So basically, we're still jumping back to the story of the kind of like the bare metal and the virtualization stuff, but in a way more flexible and fashioned way. The similar story has been happening with the platform as a service world, where Cloud Foundry was the open source tool, the set of tools that have been developed as kind of like as the easy going around approach to run your own Heroku on your own data center or something like that. It was great, but it was still not the final solution for the developers and for the full flexibility of what the people could be looking for. So honestly, I do feel that this slide is a little bit incorrect, because like many of you may know that containers as the big thing, as the technology thing, have not been developed and appeared on the stage in 2013. They have been around us like way before, with the tools like LXC, like OpenWZ, with the different stuff that has been used in the Linux kernel, like namespaces and C groups. But basically what Docker has revolutionized by making it its appearance in 2013 is the adoption of the container tools. The availability of the container tools for the developers, for people who just shouldn't care about anything, just like, I'd like to kind of like write my code, package it into some kind of the bundle form if it does exist, and be pretty much sure that the necessary level of abstraction and isolation does exist, that it would allow me to run the same piece of code either on my laptop, where I've just developed it kind of like a few minutes ago, where the same piece of code will be run in the same efficient manner as like I'm gonna do somewhere in the public cloud, on a private cloud, distributed all around the globe. So basically that was the thing, the big thing, then the big solution why Docker became so much popular and still does exist as like one of the most notable tools in the modern cloud native and innovative world. The big downside of Docker, of the pure Docker, was the fact it was like barely scalable up to out of the single host, because like when we're speaking about the single container runtime, we're speaking about the container runtime that does exist on your, again, like your single machine, on your laptop, on your server somewhere in the data center, like all that stuff. So the community has been like the community and the consumers have been in looks for the tool or the tools that would allow us to run the same Docker containers, so like whatever containers, like nobody like was curious, like it didn't matter like when we're speaking about containers, like any stuff, like literally by the end of the day, we've been looking for the tools that would allow us to run that stuff everywhere at a different scale, and literally in the scale of the potential of the full globe, you know, like with the various regions, you know, like potentially if we're speaking about some piece of software that should be run like literally from the Pacific region to Europe to Asian regions, like all that stuff. So the tools that would allow us to run that containerized stuff have been appearing on the stage like close to 2015. There've been a bunch of them. So many of you may remember tools like Mesos, the tool named Docker Swarm, and obviously all of you know the tool named Kubernetes. So Kubernetes has, again, like the brief story for those of you who don't recall that or do not know that, but Kubernetes was a tool that was originally developed by Google, inspired by the internal tool that has been used at Google for running the internal stuff, kind of like, again, like the orchestration layer and like highly containerized stuff, which is called Borg within Google. So basically, the group of engineers and some smart people from there have been deeply inspired by Borg, but Borg was like heavily reliant on the internal Google infrastructure and the internal Google tools. So basically, they made an extract of that, and the new tool has been developed. The new open source tool that could be used by anyone, everywhere, and in the different scenarios. So we know the tool as Kubernetes these days. And basically that was kind of like that big step towards to building the huge and cloud native infrastructure, something that I mentioned to you together with building the CNCF as the foundation, and basically with the kind of like the cloud native movement in the world, in the technology world in general. So basically something that I've already shared with you on one of the previous slides, that like 10 years ago we founded CNCF, the group of companies and the vendors who did exist in the cloud native space at that point of time. Like they've been heavily interested in that, and basically as the foundation we've defined our structure, where the foundation itself is responsible for the different areas of kind of like of the cloud native life. And it was also supported by the huge community that was at that point of time emerging and growing, and literally these days is one of the biggest open source communities in the world. The next big thing that has happened in the next year after that is the inception of the second project to CNCF, and it was Prometheus. So yeah. Well, as I mentioned before, we had no intention to build a Kubernetes foundation. We had an intention to build a cloud native computing foundation. So Prometheus as the essential and necessary monitoring and observability tool have joined the family of the cloud native of the CNCF projects. And also the second big, like more formal news is Dan Kohn, one of the most notable people and humans in the past in the technology world, have joined the CNCF as an executive director. So and you know, like the next every single next year after that, we've been facing some kind of the, you know, like the next big revolution or something like that. So there've been so many people at the local meetups or the podcasts or like some community groups, like whatever, have been speaking about like and all the time chatting about like, well, what's the next big thing? So basically in 2017 it was WASM, the next big thing, and also if you kind of like the container wars, container runtime, not the conflicts, but yeah, you know, like some the community has been trying to define what is the best and the unified container runtime you would use for all this stuff. So basically at that point of time, you know, like we've been speaking about Docker, and Docker has been literally kind of like the default solution for running containers. But at that point of time, Docker is a tool. It was like a little bit more monolithic than these days. So Docker as a company has made a decision to kind of like to extract and open source some of the components and like move them into the kind of like the independent tools, some of the components of the Docker as the big product. And the container runtime was extracted, and these days it's been known as Containerd, which is the pretty much well-known container runtime these days. Another container runtime that was widely used at those days, but later on, some of the concepts have been merged into the different stuff, and it has kind of like lost its like emerging popularity. So it was Rocket, originally developed by the company called CoreOS, that was later acquired by Red Hat, that was later acquired by IBM, and like all that acquisition wars. And Rocket has been, so Rocket as an open source project, it was donated to CNCF. Some of the companies have been kind of contributing to and like making the new life of the project. But basically, the community had a feeling like by the end of the day, there was a feeling that like there is no need in kind of like in kind of like this project doesn't gain so much attention as it could, and eventually it has been archived by CNCF, still receiving kind of like the ultra minor support by the foundation, but like with no big movement in the development. And the next big thing that has kind of like also appeared on the stage in 2017, it was WASM. Basically, you know, like the subset of tools for running the sandbox, ultra lightweight environments, and it was like literally, you know, like back in 2017, I had a personal feeling that WASM is the next big revolution. It is, but it does hold its own niche these days. So yeah, the next big thing that also kind of like we've been facing was about the serverless. At that point of time, Knative, original the project developed by Google, these days also hosted by CNCF, has emerged. And also the concept of the micro VMs like Firecracker, originally developed by AWS, have appeared on the stage. So basically, you know, like that was kind of like the stuff we've been focused on so much. OpenTelemetry, we've been speaking about OpenTelemetry today. It was kind of like the movement towards making the observability standard enough. And basically OpenTelemetry as a project, it has appeared on the stage by merging of multiple projects in the cloud native ecosystem, including open census and open tracing, and kind of like having some contributors from the various observability projects as well. Looks like I have to speed up a little bit. Another big thing that has been on a stage a couple of years ago, well, it still is, but then at that point of time, it was the big thing. It was eBPF. And basically the emergency of eBPF is the mature technology. So basically it was the and it is the revolution technology with the origins in the Linux kernel that do allow us to run the sandbox, kind of like the sandbox environments in the privileged mode, and like basically allow us to use the networking stuff in the like purely native cloud native way. With the kind of like the efficient speeds and official security on top of it. The projects that do exist in the cloud native world that truly benefit from the eBPF as a concept and as a technology, so much well known as Cilium, one of the literally one of the most widely used container networking solutions these days, and Falco, one of the most notable security tools. Yeah, so we had to speak, obviously we had to speak about AI in this deck in 2025, but in 2023, Kubeflow as the, well, at that point of time, it was more well known as kind of like the ML tool, the MLOps tool that has joined CNCF. So basically Kubeflow, it was originally the tool that was also developed by Google. It has been powering some of the internal and kind of like the products that have been existing in the GCP world for their customers. And basically, it was kind of like the similar concept of like extracting some of the internal proprietary stuff, putting that in the open source fashion, and kind of like making it available to anyone to deploy everywhere. Basically, it just in a few words, Kubeflow was kind of like the tool and solution and the framework for running TensorFlow on Kubernetes. Pretty easy. But basically, it was kind of like the first big AI and ML focused project that has joined CNCF, and that did allow us to kind of like to merge these big words of the cloud native, which became well pretty much boring. As much as you know, like the biggest part of my talk today, with the AI stuff that we are kind of like so much excited about. Yeah, so like the ecosystem around like AI has also been growing. Kind of like last year we've been doing the CNCF and like the entire foundation, like the entire ecosystem around us. Kind of like I would mention that like I would mark the 2024 as the year for kind of like for the emerging AI ecosystem in the cloud native world. We've released our first cloud native AI paper, for instance, that is available right here. You may check that somewhere in the archives of our blog. And you know, like we started kind of like combining the AI stuff with some of the well-known cloud native tools like WASM, and also using the AI stuff for telemetry, let's say. And these days, so Kubernetes by itself as a project does focus on the AI enablement. The one of the most recent Kubernetes releases that has been released this year, a couple of months ago, it's literally the first Kubernetes upstream release that does have the pure focus on AI with a subset of tools and concepts that do clearly state that purpose. And also, like outside of Kubernetes by itself, multiple projects have joined the CNCF and like the entire kind of like complemented the entire cloud native landscape with the AI and like AI focus, LLM focus, and like all that fashion stuff that all of us are excited these days. The same with the agents, and one of the projects that has been with the CNCF for the last few years, it's called Dopper. So these days, it's like one of the projects that does implement the agentic workflows, for the stuff that is kind of like pretty much useful these days for what we're doing in the cloud native world. The big thing about AI that I'm pretty much excited to see these days is the wider adoption of the so-called, like many of us call it open source AI, more of us call it kind of like the open weighted AI and like all that stuff, because like not all the models are truly open source as the open source code, but it's still like the big step towards like openness in the AI ecosystem. So DeepSeek was one of the one of the biggest samples of like how the like literally the production ready model can be open and widely used. These days, you may see the wider variety of models, including the Google's Gemma, including some of the different vendors. Like today, OpenAI has announced that their GPT model can like they have released their open GPT models for the wider consumption and like all that stuff. So. Again, like it's not so much open as we would expect from like the regular definition of open source. At the same time, like it's kind of like closer to what we're expecting to. All right, one of the final slides in like 5 minutes past time. So basically, the future here is that like the beacon and the unified ecosystem. So I'm not just speaking about the AI here, but the AI is one of those components that do help us, like basically that acts as the kind of like the glue that does combine all of those necessary components that we may have. Starting from the hardware level, where we have like truly the bare metal experience or the vendor supplied experience for literally providing us some kind of the physical infrastructure, the logical infrastructure that is being comprised either by the big public cloud vendors or some of the stuff that you may use in your kind of like on your own premises. And later on in the stack with the platform and kind of like literally by the end of the day, we are all interested in the end user workloads, because like this is something that like we are using. And this is like all of those pieces of all this big stack and like big picture, they're all being comprised by AI. And AI is literally the next big thing that we may do and we may build together in open. All right, so the final slide. So we do run as the foundation. We do run multiple big events all around the globe. Most of them have already happened. The next big one will happen in North America, in Atlanta later this year in November. So whoever will be there, please join us right there. And that's it from me. And apologies for staying 7 minutes late. Thank you.
Amazing. Thank you so much, Ihor. That is it for us this evening. So apologies we don't have time for questions, but if you come to the pub afterwards, maybe you can take some questions there. We're going to go to the conductor, which is just out the door, straight in front of you on the left. And when you head out, please remember to return your key fobs. And I will see you again first Wednesday of next month, which will be September. Thank you so much. Have a good evening.